Okay, in this experiment, we are going to start the logic gates. In this logic gates, we are supposed to verify the truth tables of AND, OR, NOT, XOR, XNOR, NAND, okay, NOR gates. Okay, initially, this is a power button. Whenever it will be power on, okay, and we have to connect the AND gates first. For the AND gate, there are two inputs. These two inputs have to connect to this logic input section, and one output is there which is in yellow color, that have to connect to the logic output indicators. Okay, initially both the inputs of AND gates are 0 and 0 because no light has been blinked. Okay, initially it is in off condition, so both the inputs are 0 0. When 0 0 is given as an input for the AND gate, the output should be 0 because the AND is going to perform the multiplication operation. Okay, when both the inputs are 0 0, the output should be 0. Now next possible condition is first input is 0, second input will be 1. When 0 and 1 are two inputs for AND gate, in that case also the output is 0 only. Okay, third case is when input is 1, second input is 0, 1 and 0. For that, the output of AND gate is also 0 only. It will be logic 1 when both the inputs are 1 and 1. 1 and 1. For this last case only, the AND gate is going to provide the logic output as 1. Okay. And next we are going to do for OR gate. For the OR gate, again there will be two inputs and one output. The OR gate is going to perform the addition operation. Okay, switch on the power supply. Initially, when both the inputs are 0 and 0, the OR gate will produce the output as 0 only because 0 plus 0 0. Okay, next case is 0 plus 1. 0 and 1. When 0 and 1 are the inputs for OR gate, the output will be 1. Next case is 1 and 0. For 1 and 0 also, the OR gate is going to produce the output logic high, that is 1. Last case is when both the inputs are 1 and 1, the output will be 1. Okay, that means in the OR gate, except when both the inputs are 0 and 0, rest of all the three possible combinations will give the output as 1 only. Okay, OR gate. So the next one is NOT gate. For the NOT gate, there will be only one input. So the NOT gate is going to give the output as reverse of the input. Okay, when the input is 0, for the NOT gate will produces the output as logic 1 high. When the input will be high, the output of the NOT gate will be 0, that is logic low. Okay, next one is for the NAND gate. For the NAND gate, again there will be two inputs and one output. NAND gate will performs the exact opposite operation of AND gate. Okay, in the AND gate, we got the logic 1 as a output only in the case of both the inputs are 1 and 1. Okay, but this NAND gate will gives the exact opposite of truth table of AND gate. Now switch on the circuit. Both the inputs are 0 and 0. When both the inputs are 0 and 0, the output will be 0 in the case of AND gate. As it is a NAND gate, it will give the opposite of AND gate, that is 1. Now next case is 0 and 1. When 0 and 1 will be given as a input for the NAND gate, actually from the AND gate the output should be 0. But the NAND gate will produces the output opposite of AND gate. So 0 and 1, the output will be 1. So next one is 1 and 0. For 1 and 0, the output will be 1. Next last case is double 1. When both the inputs are 1 and 1, the output of the NAND gate is 0. Okay, in the AND gate, actually it was 1 for 1 and 1, the output was 1 in the AND gate. As it is a NAND gate, opposite of AND gate. Okay. So next one is NOR gate. For the NOR gate, the two inputs and one output. The NOR gate is exactly opposite of the OR gate. Switch on the power supply. For both the inputs as 0 and 0, for the NOR gate, it will produces the output as 1. Okay. So when 0 and 1 is the input for the NOR gate, in the OR gate actually it was supposed to produce as 1, logic 1. But as it is a NOR gate, it will produces the output as logic 0. Next case is 0 and 1. For 0 and 1 also, the NOR gate will produces the output as 0 only. Okay. Actually 0 plus 1 will be 1 in the case of OR gate. As it is a opposite of OR, it will gives the logic 0 as a output. Last combination is 0 and 1 and 1. When both the inputs of NOR gate is 1 and 1, the output will be 0. In the OR gate, actually it was given as 1. Okay, but in the NOR gate, opposite of 1 is 0. Next case is XOR gate. In this XOR gate, when both the inputs are same, the output will be 0. When two inputs are different, in that case only the output will be 1 for the XOR gate. Let us check. So when both the inputs are 0 and 0 for XOR gate, the output will be 0. Next combination is 0 and 1. These two inputs are different. 0 and 1 both are different. So in the different output case, it will produces the output as 1, logic 1. So next case is 1 and 0. In the 1 and 0 also, as these two inputs are different, the output will be 1. Last case is 1 and 1. As these two inputs are same, 1 and 1 are same, so the output will be logic 0. Okay. And next one is XNOR gate. XNOR gate. So in order to connect the XNOR gate, the output of XOR gate is connected to input of NOT gate, and the output of NOT gate in turn it is going to be connected as a final output, because in this trainer kit the XNOR is not present. So XNOR is equal to XOR plus NOT. Okay, XOR plus NOT is equal to XNOR. The XNOR is opposite of XOR gate. In the XOR gate, when both the inputs are different, then only it will produces the output as 1. Okay. Here in this case, it is quite opposite. So when both the inputs are 0 and 0, 0 and 0 means both the inputs are same. In the same input case, output is 1. Okay. When two inputs are different, the output will be 0. And the third combination is 1 and 0. In 1 and 0 also the output will be logic 0. When both the inputs are 1 and 1, as these two inputs are same, it is going to give the output as 1, which is exactly opposite of XOR gate. Okay, these are the two tables of logic gates.